I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. As always, we have a great webinar on tap today, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you missed any or all of today's event, you will be able to access it later on. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for our speakers, please don't wait, don't hesitate, just use your GoToWebinar control panel and submit your questions. And we will take as many questions as we can near the end of today's webinar. And with that, we'll go ahead and kick off today's webinar, which is Empowering Financial Institutions to Use Open Source with Confidence. Our speakers today are James McLeod, who is Director of Community at FINOS, and Jeff Crum, who is Senior Director of Product Marketing at WhiteSource. Welcome, gentlemen. Thanks for joining me today.
Hi, Charlene. Thank you very much. This is James McLeod, Director of Community at FINOS. We are the Fintech Open Source Foundation for anybody who would like to look us up online. And I'm actually joining everybody here from London, so thank you very much for joining. So as I get started on this webinar, the first thing that I'd like to say is that the future of finance will be open source and real time. Now, what that actually means is that there'll be more collaboration between financial services companies. There'll be a lot more sharing and a lot more innovation. And also, as we kind of get into this world where everything becomes more real time, we need to be able to move faster, which means that there will be a lot more problems to solve. And within engineering, if you are an engineer, you will know that there is a limited amount of resource within engineering right now. And so for us to be able to share and also innovate and solve these problems, we all need to start working together in a very different way, which means that we will be working cross borders, which means across financial services companies and also across different countries and boundaries. Hence the reason why financial services will be open source. So that's not saying that things aren't happening right now. So within financial services right here, right now, there is actually a lot of activity that's happening, both within GitHub, as you can see on screen right now, but also within other systems of collaboration, including GitLab or Bitbucket or wherever other people are actually collaborating. But for all intents and purposes, the figures that are actually showing on screen right now, which have actually been provided to us from GitHub, actually show that 355,000 commits are being made by financial services companies, as well as nearly 45,000 repositories are within GitHub from financial services companies, and also nearly 25,000 committers are committing and collaborating within GitHub right now. Now, the interesting thing about these numbers is that these are coming from where GitHub are able to identify where the collaboration is coming from. So if you've got a financial services email address, that's what's actually being used to provide these numbers. And as we move further into authentication through SAML or other forms of single sign-on, I'm pretty sure, in fact, I'm very confident that these numbers would actually be higher than this. So the one thing that we need to note is that open source in regulated industries is not easy. And that is actually the plain truth. Within a regulated industry, we need to make sure that we can be scrutinized. So we need to make sure everything that we do is auditable, and the regulators also have a view into everything that we're doing. So if it's that difficult, why is it that we actually need to start open sourcing in the first place? Well, if you imagine all of the financial services companies, both big banks and smaller fintechs, with all of the various different problems and innovation that they're trying to solve, you can imagine all of the duplication of effort that's actually happening if all of those institutions were to remain siloed, and if people were to be solving those problems as single developers. And so open source is actually a great way to remove that duplication of effort. Plus also, if we are open sourcing our libraries or open sourcing components that people can share, the plain truth is that actually increases the quality of the software that we produce, because the more eyes that we have looking in on our software, the greater the quality that software engineers put into the development of their products. It's a byproduct of open source. Everybody wants to show themselves as being an awesome engineer. Therefore, quality also increases. Plus, open source isn't just about code within repositories. I mean, that is a big aspect of open source. But we can also collaborate across standards, and we can also collaborate across different regulations that we have. And so not only are we sharing code in open source, but we're also technically architecting different standards and different ways that we can pass information from one regulated environment to another, which means that we don't have to keep transforming data. We can actually take data in an existing format that the open source community agrees upon. So what are the challenges? Well, there are legal challenges. Also, we need to make sure that everybody has an open source policy, which means that each corporation or each firm that's providing open source materials has an open source policy that allows their engineers to do that. Plus, we need to make sure that all of the various different licensing agreements for engineers and people to be able to contribute are actually there, and they're called CLAs. And so having CLAs in place is also something that we need to be able to provide for our engineers and other people. Plus also, not everybody's heard of open source within organizations. And so being able to provide the narrative and being able to provide the training is also something that we need to solve. And then there's also the mechanisms through DevOps, which is something that we're going to be talking about today, and how we can actually do that safely. So if you look at the traditional ways in which software has been produced in the past, and I'm saying the past because this is actually one of the narratives around digital transformation that's happening in finance and happening in other industries. What you have is the production of a product. In the case of software, that product is actually code, which gets packaged up and then distributed, whether that's online or another distribution channel. And then you market it, and then it actually goes out to your consumers, which means that it's actually a very kind of industrial revolution kind of production line that you're creating here, where the feedback loop from production all the way through to consumer is extremely long. And so if there's something wrong with your product, or it doesn't actually hit the demands of your customers, you're not actually hearing that until this entire linear production line has completed, and then your consumers might come back to you, which means that the lead time for this type of model is actually very long. And in the financial services industry, as I'm sure is very apparent within other industries, if you take this lead time and then you put it against a waterfall model, so at the top, in the top left, you have development. So your development teams develop your product, and then you take that product and you give it to your integration testers, because there's an external API that needs to be called, or an external system that you depend upon. Then after that integration testing has taken place, it goes on to your quality engineers or your QA teams to test. And then your security team then tests all of the penetration testing that may happen. Across each of those various different milestones of testing, if there's a failure, it then needs to come all the way back into development for that release cycle. And this is what actually increases cycle time. And so cycle time and lead time are actually related to each other. So the lead time is the total amount of time from development through to live, with each of the cycles being the intervals between testing and other places where you pass that software across to other people. And as you can see here, the total amount of cycles and failures account for the increase in lead time through this type of model. So open source. actually helps us break this by turning all of those long lines and long arrows into circles. So what we actually have is an ecosystem where the consumer, as you can see on the right-hand side, is actually part of the development cycle with the platform and with the development team. And so you get this nice circular ecosystem of development into test and then into your consumer. And this is continuous, and it's a continuous feedback loop. So the actual cycle time is brought all the way down. And the great thing about this type of pattern is that the consumer is actually brought very close to your team, which means that between version releases, if there's an issue with your code or something needs to change, then that feeds back straight into your open source teams. And this is actually really apparent with Facebook through React, and other open source tooling that they provide, Airbnb and all of the various different JavaScript standards that they provide, and also Stripe, which with their online economy built on OSS platforms. Now, when we take that open source model and actually bring it into our feature teams or our teams within our organizations, this is what the DevOps pipeline or feedback loop looks like. And as you can see, DevOps isn't just about automation and tooling. DevOps is actually about how engineering and also the production of your product relates to agile, automation, and also how it creates a different culture of engineering. And as you can see, a lot of the manual testing that can happen when you pass code along a linear waterfall path is actually being done by automation, and also a lot of both licensed and also open source tooling. Now, by following this model, the great thing is that you really increase the pace of delivery. You really increase the pace of all of the efficiencies that are being, enabled. You also increase quality, and the velocity drive is enormous. And so by taking a look at the various different milestones that have been created whilst open source has been in play, as you can see on the left, open source created the specs for MapReduce, which meant that big data was introduced in 2004. And then Amazon launched AWS in 2006, and so the cloud was born. Then we had the introduction of NoSQL with MongoDB in 2007, and then blockchain and also Bitcoin was introduced in 2008. And if you kind of fast forward that to Hadoop in 2011 and how Hadoop has actually created that community of big data engineers, plus also with the introduction of JavaScript through Node into the Linux Foundation in 2015, and then Google's production of TensorFlow within open source and machine learning in 2016, you can see that actually all of these various different related activities through open source have created very big splash technologies that are actually quite mainstream now and have been adopted by big organizations. So with that, I'd like to pass you over to Jeff, who will show you from a WhiteSource point of view about shift left.
Great, thanks, James. This is Jeff Crum again, Senior Director of Product Marketing at WhiteSource. And what I wanted to do is, James got a little bit into a lot of the processes that have evolved in terms of increasing adoption of open source and also moving from more of a linear type of workflow into something that's more cyclical. And so what I wanted to do is take that and get into a little bit more detail about open source and how shift left in particular helps empower the usage of that. So when you talk about empowering financial institutions, for example, to use open source with confidence, part of that is ensuring that the open source components that you're using in your applications are secure, and doing so in a way that's efficient and cost effective. So obviously you want to make sure things are secure, but you don't want to spend so much time on that ensuring of security that you're not getting anything else done, or else what would be the point, right? So part of the efficiency can occur as you shift left your application security, putting more of it in the hands of application developers. So in this section, I'm going to talk a little bit more about that and how you can go about shifting left and doing that successfully. So if you go to the next slide here, the three components of this that I'm going to get into is first, we'll talk about how far left you can go, what's possible, and what are organizations doing today. Could we go to the next slide? There we go, thanks. There might have been a little delay on my end. Anyway, so we'll talk first about how far left you can go, what's possible, and what are organizations doing today, and then we'll talk about who owns application security as you shift left, to what extent do developers own application security as you shift left, and then finally we'll talk a little bit about what types of tools you need for application security as you shift left. So in this first part here, how far left you can go, if you go to the next slide there, what I want to take a look at is take a look at this diagram here where it talks about when is the optimal point to integrate security checks into the software development lifecycle. So if you take a look at that from planning to coding to the build to deployment and maintenance after that, there's various points within the software development lifecycle where it could make sense to integrate security. And a lot of the tools that are out there today have multiple points of entry there. But if you take a look at what makes sense from an efficiency standpoint, if you look at the next slide, you can see that the cost of fixing security and quality issues rises significantly as you are further on in the development cycle, which of course is pretty intuitive, right? Because if you're just a coder and you're doing, you're ensuring security there, you see some issue, you fix it, that's relatively inexpensive. When you go on to the build part of that, that could cost a little bit more to backtrack and fix things from there. Once you're in QA and security, of course, the expense is going to rise as things are detected there. And of course, once something rolls out into production and security issues are discovered, that's where things get the most expensive. So this is part of what we're looking at in terms of the rationale for shifting left and being able to realize more of that cost savings. Taking a look at the next slide, as you can see here, many companies are already implementing application security testing in that build or even pre-build stage. You can see these two numbers on the left add up to 66% of companies that have already implemented application testing during those earlier stages. So shift left is already happening, and we expect it to continue to increase. And if you take a look at the next slide, in fact, we also see a strong correlation between companies where developers rely heavily on open source components and companies who test their application security before the build in more of a shift left mode. So both of these types of characteristics, whether it's the usage of open source or the earlier shift left testing, are characteristics of a mature DevOps organization, kind of what James was alluding to earlier and some of the things that he showed you. So it's no surprise here that we're seeing these types of things correlate. So that's the first point, really, how far left you can go. You can really go very early on into that development cycle, and we're seeing organizations do that today. If you look at the next slide, and we'll focus then on who owns this, who owns application security then as things shift left. Looking at the data on the next slide, if the goal is to integrate security earlier on, there's obviously going to be a trend toward application security being owned more by developers and developer-related teams. 72% of the respondents here stated that ownership over AppSec lies on the software development side, and you can see the numbers add up here between DevOps, between developers, between team leaders on software developer teams. So with this move to shift left, you're seeing more security responsibility being transferred there, which would make sense, of course. And looking at the next slide, if you look at this across different types of organizations or different sizes of organizations, I should say, if you look at who owns day-to-day operational responsibility by company size, smaller organizations, which have a tendency to be able to change processes and move a little faster, are seeing more progress and turning more ownership over toward developers. But even medium-sized organizations, large enterprises, are all showing leftward movement as well. So we're seeing this trend out there, and to kind of align with that, on the next slide, 36% of developers say that their company is providing them security training that helps them code better. So as companies are shifting left, there's a realization that there needs to be more and more education on secure coding practices as well. So this 36% number is obviously not a majority, but it's something that's growing and something that's higher than we've seen in the past. So that then, that of course takes a look at who should own this. The third part I want to look at here, starting on the next slide, is shifting left with the right tools. Because one of the things to think about here is that even though as we shift left and application developers have a greater ownership stake in application security, they don't have an exclusive ownership stake. So you can't have development tools be the sole focus of your application security strategy. You really need a couple of components. So if you look at the next slide, what I'm outlining here is the need for two types of categories of tools, right? The developer tools, which I just alluded to, which of course are critical because application security, as we talked about, is shifting left, moving more and more into the responsibility of developers. But at the same time, that doesn't mean that there are no other stakeholders in the organization that care about security more, that need to have visibility into these things. You need to be able to have what we're calling governance solutions here, which are those tools used by security teams, management, and others to get full visibility and control over the security risks in their software. So these are two, it's important to differentiate between these types of solutions and look for solutions that include components of both of these. The developers' tools to make their lives easier, to be able to implement best security practices and pick up things as they're coding to fix them right away, as well as the governance solution so that management, security teams, and others can have visibility into what's going on with application security across the organization. And then this is kind of outlined in a little more detail on the next slide, where you can see kind of the needs of these spelled out further. So developers tools, they need information on issues, they need to be able to remediate things quickly, and they need integration with development tools. And then on the governance solution side, that visibility and control and reporting and all of those things that I just mentioned. So finally, to wrap up my section here on the next slide, just to kind of do a quick recap, how far left you can go? Well, we're seeing organizations today going very far to the left into the build and even the pre-build stages. The earlier you can go, as I mentioned before, the less expensive it gets when you have security issues that come up. Who owns it? Well, there's a tendency, of course, as we shift left into earlier in the development cycle, you're going to have greater responsibility on your software development and related teams in terms of who owns application security. But in point 3 that I made, that doesn't mean it's an exclusive ownership. You need to have tools that are important to both the developers as well as to the managers and the security professionals and others that are responsible for these things and key stakeholders in these areas as well. So with that, I'd like to turn it back over to James, who will take it from here.
Hi, thank you very much, Jeff. So I'd like to remind everybody on the line that you can actually ask questions. So feel free to ask questions for us either in the Q&A after we've gone through our slides, or if you actually just type them in to the text box that you may have in front of you, feel free to do that now. Okay, so it's really good to hear where Jeff is describing shifting left. And so what I'd like to do now is actually show you what that actually means when it comes to doing open source development and how that is actually achieved. And so what you're seeing on screen right now is the FINOS vision for a Fintech open developer platform that we're continuously working upon in order to create that shift left environment for open source developers within financial services. And what I'm going to actually focus on is that arrow right in the center of the screen, starting with software contributors on the left-hand side and then going through to software consumers. And so as you can see, the very first arrow leads to GitHub, which is actually where your software team will be writing their code and where they will be collaborating. And so this is a very human meets technology area. Because if you work within a feature team, you know that within Agile, whichever flavor of Agile that might be, this is where people actually collaborate and they work on stories and they do all of their prioritization and all of their grooming of stories. Plus, you can also have all of your various different issues within GitHub, and you can also have your Kanban boards as well, so your stories can reside there. So GitHub is kind of where Agile meets development. It's a very social platform, and it's a place where developers can meet within their teams, and people outside of those teams can also raise what we call pull requests into those teams as well, which means that you can get outside contribution into that team as well. Now, as we go from left to right, When we're ready to actually make some form of build, we will create a build trigger, which then is caught by our continuous integration kind of area. In this case, is Travis CI, but there's no reason why internally that could be Jenkins, or it could be Circle CI. And so this is kind of your test runner. And this is where all of the various different tests that I showed or alluded to a few slides back within that figure of 8 are actually run within your continuous integration platform. And this is where automation within DevOps actually takes effect. And so if on the left-hand side within GitHub, somebody commits some code where a unit test fails or a BDD script fails, or your linting, isn't compliant to your linting rules, your continuous integration area will pick that up because it's actually running the same test as your developer would be running within their development platform. Now, if those tests pass, we then go to the right again, which is where we run all of our security testing, which is what Jeff was describing. And this is where DevOps meets security and cyber. And you may have heard the phrase DevSecOps, which is an extension of your engineering team to also include cybersecurity. And so DevSecOps isn't necessarily just the tooling that you're running, although the tooling actually does help you within your automation pipeline, but it's also the team members that you have within your teams as well. So if your team also includes people who are very security aware, that also contributes towards DevSecOps. And if you're also integrating a platform like WhiteSource into that tool chain, that also contributes to DevSecOps. And so it's shifting left within security is how early can you pick up on all of those security vulnerabilities? And actually, can you get stories into your development that also allude to security as well? So maybe your agile definitions will include security checklists, etc. And so, as you can see, having a tool like WhiteSource and having security within your teams is actually a real big shift left on development. Then once all of your security tests have passed, so you've got another green tick, you then go across to continuous delivery, which is when rather than passing that down the linear path, down the waterfall to get built and then shipped, your CI/CD platform does that for you, because according to your agile definitions and also according to all of the automated tools that you have on your tool chain, your build is now safe to ship. It's gone through all of the various different checks and security measures, and we can now pass that on to containers. We can pass that onto Kubernetes. We can use OpenShift. And we can even pass that into open source registries. So as we move further to the right now, people can actually engage with that through Maven or through NPM or NuGet. And that's when you actually start hitting your consumers. This is where your customers of your software start using what you've shifted or what you've shipped, pardon me. And then that cycle just repeats around, the agile cycle and the DevOps cycle. And so you continually go around that loop, which reduces the amount of lead time and really reduces the cycle time and really does shift you to the left. Right, sorry, I am, okay, I'm back. So how is that actually done within the Open Developer Platform? Well, actually, everything within ODP starts with whether the engineer that is making a pull request has got the licensing agreements in place in order for them to do it. Because as you're probably aware, within software engineering for open source, you have different licenses such as Apache 2 or MIT. But what we need to make sure is that all of the various different contributions that are coming from outside of those teams, all of the intellectual property that goes into that pull request is actually donated back to the team, so the origin of that project. So you kind of say with that pull request that I'm okay with the team who I'm making this pull request to, I'm okay for them to actually own the code that I'm giving them. And that's what a CLA is. it's actually a contribution license agreement, and it just says, I'm okay with you having my code. Now, the CLA bot looks through all of the various different contributors to a repository and makes sure that your name is on there. And so it does this for every pull request that's made into that repository. Now, the great thing about integrating a bot into this cycle is that you don't need to go through reams of paper to see if somebody is making a valid contribution. The bot will look at you against a configuration file, which says, yes, it's okay, we know who this person is. And as you can see on this slide, we then give real-time feedback to say, yes, it's okay, we're willing to take your pull request, thank you. You know, you've signed a CLA, or your firm or your corporation has signed a CLA on your behalf. Or if you don't have a CLA, we then give you real-time feedback to say, you don't have a CLA, please go to this URL and work with your product owner or work with your firm to have one signed on your behalf. Or maybe if you're a contractor or you're a freelancer or an independent consultant, you can do one as an individual as well. But this is where that real shift left feedback loop comes into play. So you're not waiting an eternity for an administrator to come back and say that everything's okay. The bot does that for you against a configuration, which is actually a real accelerator when it comes to real-time feedback and giving you the thumbs up to continue with your contribution. Then as we get beyond the CLA bot, when we know that you're okay to be making that pull request, that's when the continuous integration kicks in, and that's when all of the checks are made against all of the various different tools and all of the various different unit tests and all of the linting rules, which define the quality of your code, and all of the BDD tests, which are behavioral driven development, so make sure that the user journey through your application are in place. And as you can see here, the person who's made this pull request, all of those ticks are actually passing. So everything is green here, which means that against the Agile definition of done, which will also include all of these checks needing to be passed, this particular pull request is good to go. But counter to that, if anything fails, so if you knock out a unit test, further down the line because you've made a change to an API, and it just so happens that your change has failed somebody else's unit test, then one of these ticks will come back as a cross, and therefore you can't ship that code. And the great thing with that is also a shift left as well, because it means you've got immediate feedback to say something's not right here. You're actually breaking somebody else's code somewhere else within the system. Can you please take a look, at the contribution that you're making to make sure that these checks come back as ticks rather than as crosses? And then once you've gone back and you've raised the pull request again, and then the CI environment has run your tests again, and everything comes back as ticks, you can then go on to the next phase, which means the cycle time is increasing and you're able to get shipping faster and faster. Now, this is actually a sketch that I've made just to show what contributing to open source looks like within a financial services environment, because within financial services, we do have various different financial services firms with different levels of access to external systems like GitHub. So if I go from the bottom, the team that's got the red kind of circle around it, at the moment, this team is advancing into open source. So they're working with their cybersecurity teams and their internal governance teams in order to get access to the outside environment of GitHub. So even though they're blocked right now and they can't make a contribution, they are actually moving through all of the various different checks that need to be made in order to be able to contribute to GitHub. And so within FINOS, we have organizations that come into various different groups in order to learn how they can actually get into GitHub and how they can start becoming effective and make an impact within GitHub. So it just so happens that this team can't contribute, but they are looking to contribute, and they often come to us for help. Now, the amber and the green teams. The amber team might have access to GitHub, but it might be limited to certain people, or it might be limited to certain consultancies or third parties who work for them. But they are able to access GitHub, and they are able to make pull requests against projects, as are the green team, who are fully, they've got full access to GitHub. The actual confidence of open source is full, and they've got full access through CLAs, and engineers are, both consuming and contributing to open source effectively. Now, both within the amber and the green kind of phases, when a team actually contributes to a project, and as you can see within GitHub, there are many, and I've kind of highlighted these using clouds. Across all of those various different projects, if they are also hooked up to a CI/CD environment that has real-time vulnerability testing, when that build trigger is actually made, just in the same way as I described before, that CI/CD platform will also trigger with all of their security testing. So not only will the unit tests be passing and the BDD and linting tests be passing, but they will also go through some automated checks and balances to make sure that all of the various different security tests are passing as well. And if all of those tests pass, then they go further to the right. So you either go into NPM, which is an open source repository, or maybe OpenShift for container management, or maybe into the cloud, for other containers and, other ways of actually storing and running your code. And so through this cycle within financial services, if all of your tests pass, then you can, ship your code. But if there are any failures within that, then you have to, like I described before, investigate those security failures and see the reasons why, you're getting a security failure against a certain build, just in the same way as if your unit tests or your BDD tests fail. Now, when it actually comes to security, without doing manual security and penetration testing, when you actually bring that through an automated system into your team, what you need to provide your team, and this is where shift left really happens, rather than having a central team of security engineers who are telling you what you're doing wrong, you actually bring all of that information into your engineering team. So your engineers within your feature team get all of the information that they need in order to understand, the current state of their project. And so within that CI/CD platform, where you've also got security integrated, you would also provide reporting, such as what we're seeing on the screen here right now. And as you can see within the bot GitHub ChatOps repo, currently there are vulnerabilities within that. So you can see that there are red dots and there are amber dots. Now, if this was to come back, at the end of, some form of waterfall process, where your development team haven't seen their code, for a couple of cycles, then all of a sudden, maybe a few days later, they get a report back to say, oh, do you realize that you've got these vulnerabilities? Then the context of the code that the team are working within may be lost, and so your team need to get reacquainted with that build. They need to rerun it. They then need to go through all of the cycles again to go through all of the various different testing. Only at that point where those cycle times are actually really big, and it gets back to the security team, only to find that either these have turned to green or that they've come back to red. But if you bring all of that reporting into your feature team or into your open source team, then the engineers who are working on the code, who ultimately want to ship their products, get to see all of this information in real time at the point of build. It's literally a few minutes, to see where things are happening, and then they can see a report like this. Then if they do see ambers or reds, you can then drill down. So rather than having some red, amber, green, rag status, in a report, if there is a red, you can then go down and take a look at the vulnerability. And so it takes you further into the detail, which is what engineers actually need in order to be able to fix things fast. And so you provide the reporting mechanism and also the mechanism for building to get into the detail. And this is true shift left. This is when we're actually talking about, metal upon metal. It's about engineering, getting the information they need at the point of engineering, rather than engineers getting the information that they need 2 weeks later after a security test team have actually done that security test. So then at the end of your security testing, when all of those green checks have passed, you can see here through OpenShift, we then start shipping. So we're happy with our unit tests, our BDD tests, our linting tests. Somebody's done a code review as well, because the pull request actually requires that. There's probably adequate documentation, but ultimately your security tests have also passed as well, and we're good to go. So that is the point where that real lead time of all of those big cycles that we had in that waterfall model comes down to, very small cycle times of, real short feedback loops, which also includes your consumers and your customers and the people who are using your product as well. Because as soon as this ships, if there's an issue there, that will come back through, GitHub issues, or it'll come back through your product owner, or whatever that feedback cycle is. Now, as you may or may not know, depending on your relationship with financial services, there's a lot of technology out there within the financial services industry. In fact, there's so much technology and so many different languages to cover that not every single tool that's out there can give you the coverage that's needed in order for you to be able to, pass just using one tool. And so within FINOS, so within the Fintech Open Source Foundation, we actually provide a matrix of all of the various different vulnerability checkers and all of the various different tools that you can run for your C# developers, for your Clojure script developers, for your Java developers, for your JavaScript developers, for your Python developers. And if you kind of like extend that into Go, C++, and maybe even COBOL, if you're running COBOL within your teams, there's a huge environment of code and languages and technologies that need to be covered, which can be filled. So those gaps can be filled using other licensed and also open source tools. And that's the great thing about that figure of 8 diagram that I showed before. All of those tools can then be plugged into your DevOps pipeline in order to close those gaps and in order for you to automate all of those various different checks that need to be made for you to move faster and for you to also increase quality. Now, within the Fintech Open Source Foundation, we also have our open source tooling group, which looks at all of the various different ways that teams can actually move into open source. And so the open source readiness group is not only looking at what the open developer platform is looking at. So the open developer platform is very much about the tooling and the technology that we need to run within DevOps. But the open source readiness is also about the governance, the licensing, audit, and all of those internal financial conversations that you need to have with people who are accountable for making sure that financial services firms are kept safe whilst engaging in the open source environment. And it just so happens that the ODP, Open Developer Platform, and OSR, Open Source Readiness Group, are very closely linked. So the developer platform actually keeps people safe whilst they're developing, and the open source readiness makes sure that the financial services firms are asking the right questions, and in response to these questions, the people who want to move into open source are given the right answers, and we're actually answering those questions together, which is also feeding open source as well, because it's an open group and people can join and people can contribute into what they've learned by going through that. And by doing that, we kind of all move forward into open source together. And as you can see here, what this is actually showing you is how a platform vendor and also an open source development team, and also the end user and the people who are integrating against different open source products, actually come together to create, you know, a big combined open source community where the people who are actually developing for that, you know, product and the people who are integrating and using it are coming together to feedback, to grow the product, to solve problems against that, to be innovative in the way that those problems are solved. And so that's why you will hear open source being described as a community, because people are coming together to talk about the problems they need to solve and to actually build upon those technology platforms, which is absolutely amazing. And this is where we go into the Q&A section of the talk. So thank you. That is my last slide. And so I'm going to pass it back over for questions.
All right, great. Yes, we have about, I would say, a good 12 minutes or so for questions. So if you have a question for either Jeff or James, please go ahead and use your GoToWebinar control panel and submit your questions. And let's go ahead and dive right on into the first one here, which is, we're planning to implement security into our DevOps pipeline. So how can I make sure my developers will take responsibility over security?
Right, sorry, there was a little bit of background noise. So I think the question was, we're about to integrate security into our DevOps pipeline. How can we make sure that our developers take responsibility for that?
That's it.
Is that correct?
Yep.
So, Jeff, are you okay if I give a response first?
Sure, go ahead.
Okay, so as a software engineering lead, so I've got a software engineering background. I'm a software engineer, and I've also, you know, worked within financial services software engineering teams. I've never had an issue with software engineers who don't want to do things fully and properly. In fact, I've often found that software engineers, alongside DevOps engineers and quality engineers and other people who are contributing to projects, actually like to have more delegated authority into that type of tooling. And so they like to have control. In fact, by not allowing them to take responsibility for it, you could find that it actually creates a little bit more frustration, because all of the software engineers that I've actually worked with want to move faster. They want to have better quality products. They want to make sure everything is secure. And so my recommendation is for you to delegate the responsibility of the integration of the security tool into your DevOps pipeline, and give it to the software engineers to own, because I'm pretty sure that there's going to be an advocate in amongst your team who will do that for you, and they will really impress you.
Excellent. Okay,
Yeah,
Jeff,
I would
do you
just
have
add
anything?
to that.
Go ahead.
Yeah, so could you actually just could you just restate the question? I just want to make sure I focus my answer in the right area.
Absolutely. Let's see. Okay, so we are planning to implement security into our DevOps pipeline. So how can I make sure my developers will take responsibility over security?
Yeah, so I think I would, James, of course, gave a pretty good answer to that, but I think I would add to that just some of the things I talked about earlier, the importance of the tools that are being used and being able to, for the developer aspect of that in particular, adopting tools that integrate into the development environment, that work natively in the environment that they're accustomed to using. One of these tensions that you tend to have with developers and security is that, of course, they want to be able to develop software and innovate and do great things. Sometimes the security mechanisms can take them away from that. And if it's doing it to the extent where they're pulling them completely out of their development work, that can end up creating a little bit of a disincentive there. So the tools, the more you can integrate those into their processes, the easier it is for them to adopt. That's what I would just add to that.
That makes a whole lot of sense. Okay. All right, great. Next question here. Let's see. What is the most important aspect to consider when shifting left? Is it the right tools or developer training or something else altogether?
I can
James, you
start
want
with
to
an
start?
answer to that, and then yeah, I'll start with
Okay,
part of an answer there, and then see if James wants to pick up on it.
Okay.
when you're shifting left, as I mentioned earlier, of course, some of the motivation around that is because it ends up being less expensive to deal with vulnerabilities at that stage. So, if you're trying to sell the team and sell the organization on doing this, that's something to look at initially. Other important considerations, though, are that as, kind of related to the previous question that you asked, as you're shifting left, you're putting more responsibility onto the development side to implement security mechanisms. So you need to make sure that you've got developers or a development team that are engaged and ready to do that. You potentially have a champion on that side that is willing to embrace incorporating security into that process. Because if you're going to try to shift left, but there's no one there that's really taking full ownership there, it's going to be difficult to do. So those are just a couple things I would mention related to that.
Absolutely. So from my point of view, it's shifting left also starts with culture as well, and how you can actually create those, fully formed feature teams. We used to call it a T-shaped model or a cone-shaped model, and it's about how you can bring engineers together to actually understand each other's discipline and craft. So creating that feature team of mixed developers, so you'll have a software engineer, a DevOps engineer, a quality engineer, and a security engineer, all working together and all understanding, that life cycle and what it is that they're actually creating, does actually go a long way as well. And that's about human relationship as well as about, the tools that you're implementing.
Okay. All right, great. Just a friendly reminder, if you have a question, there's still a few minutes left. We can get to more questions. Just use your GoToWebinar control panel and submit the question. We have one more here. Let's see. Do you have a tool you can recommend to scan for open source vulnerabilities, specifically within GitHub? James, you want to start?
Well, I mean, I could.
Or Jay?
Yeah,
Okay.
James. I mean, I could certainly speak to ours, but James, it'd be good to get your perspective. Being from a vendor myself, I'm obviously going to advocate for our own set of tools in this sort of scenario, right? So, but there are others out there where we certainly support GitHub among many others. With WhiteSource in particular, I won't go into too much of a commercial here, but with WhiteSource in particular, we support a broad range of languages and environments, including multiple repositories. So you could certainly use our tool for that, but I'll leave it to James to probably give a little bit more vendor neutral perspective on that.
Yeah, absolutely. So I answered the question correctly. Can you remind me of it, please?
Yeah, sure. Do you have a tool you can recommend to scan for open source vulnerabilities within GitHub specifically?
Yeah, so obviously WhiteSource does, and this is a tool that we're actually using within ODP to scan for vulnerabilities. But you've also got Sneak as well, which is an open source tool that does similar. You've also got Black Duck, which scans for open source vulnerabilities, and you've also got Nexus IQ, and also Nexus is like a vendor too. And the great thing about a lot of these vendors is that you can actually engage with them when you're contributing to open source, but also when you're consuming it as well, because open source isn't just about what you're giving out, it's about what you're bringing in as well. And so through this webinar, we've been talking about contribution to open source and making sure that we're safe when contributing outwards. But like with WhiteSource and Nexus and Black Duck, you can also engage with them when your developer teams are bringing things in through NPM or bringing things in through Maven to make sure that what you are consuming is also safe too. I hope that helps. But there are plenty out there, both licensed and also open source as well.
All right, great. Great. Well, let's see, we're about 6 minutes to the top of the hour. We don't have any other questions, so I do want to thank everybody who did submit questions. Those are some good ones. If you do have a question, I'm sure that the folks at WhiteSource would be more than happy to follow up with you offline if we don't, if you submit it after the webinar today. I want to remind the audience that today's event has been recorded, so if you missed any or all of it, or if you just want to listen to it again, you'll have the opportunity to do so. We will be sending out an email later on today that contains a link to access the webinar on demand. And the webinar is also going to be living on the devops.com website, so you can always go look for it there. Just go to devops.com/webinars, look in the on-demand section, and it should be right there waiting for you. And while you're there, please check out the other webinars that we have, both upcoming and on demand. Gentlemen, James and Jeff, I would love to thank you both for joining me today. Great presentation. Appreciate the information.
Thank you very much.
Thank you. Thanks everyone for joining.
Great, great. I also want to thank the audience for joining me today. And this is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody.